Sorry about that, guys. We have this broken into two videos, I guess. So I got interrupted by the little phone call. But anyway, we've got our top bound minus our lower bound. So the bounds on this, they tell us, are just 0 to 3, really. So we're going from 0 to 3, and we take our top, which is the parabola. And later on, we're going to really talk about the representative square, which, if I do in green here, would be this rectangle right here. Kind of, we're adding up all these rectangles, just like that area under the curve that you found originally. So the height of the rectangle is our top minus our bottom. So x squared plus 3 minus the bottom. Now, when you do the bottom, you got to be very careful that you put in parentheses. Negative x plus 1, and all this times dx. And you can compute that however you want to. This one's not so bad to do by hand, but make sure that you put parentheses around your second half because of the fact that this negative has to distribute into them one way or the other. So let's clean this up a little bit. We get the integral from 0 to 3 of x squared plus x. And we got 3 minus 1 plus 2 dx. We do our antiderivative, so x cubed over 3 plus 1/2 x squared plus 2x. And then we plug in our bounds, 3 to 0. If we plug in 3, we get 3 cubed 27 over 3 is 9. 3 squared is 9, 9 halves, plus 6 minus, if I plug in 0, I get x's everywhere, minus 0. So we've got 15 plus 4.5, giving us 19.5. Now, generally, as long as you can get to this point, you can either do it by hand or using your calculator, but you have your setup and your answer, one way or the other. All right. Let's look at setting up one more at least. Now, you notice in this problem, we don't have any bounds, so we have to really rely on the picture. So this one goes down 2, and then it goes, oh, sorry, it's going up 2, and the parabola is opening downwards. So we're going up 2, and then the parabola opens down. There we go, and that's nice and symmetric. So there's a nice parabola. Try my best to go through those points. That's pretty good. And then y equals x, starting at 0. Now, if you really know how to draw your parabola well, you might be able to tell where those points are. If not, you can always do this in the graphing calculator and find your intersection points. That's probably the easiest way of doing this. Or if you got to do it by hand, you got your 2 minus x squared. You want to figure out where it equals x. So let's move everything to the right. 0 equals x squared plus x minus 2. In this case, we can factor. So we're going to get to positive 1 plus minus. So x equals 1 and negative 2, which is what it looks like from my picture. Now, what we have to do is realize which one's on top and which one's on bottom. And we're looking between these 2 points. That would be our bounded region. The region's out here, and I can go between them, but I need some sort of x value to stop us. This area is going to be infinite back here. This is the area that would be between the 2. So if I was to draw my that's a very good rectangle. If I was going to draw my representative rectangle, it's something that looks like this. Top of my rectangle minus the bottom of my rectangle. So the parabola minus the line. So we got the integral of our parabola, 2 minus x squared minus our line. And we don't really need the parentheses too much on this one because of the fact that it's just x. And our bounds we just found, always start at the lowest one from negative 2 to 1, plug and chug, get a number. That's basically it for all of them.